Hello, welcome to this video 5-3. We are going to talk about relative extrema as well as utilizing the first derivative test in calculus. All right, before we have talked about f prime of x to help us determine when f of x is increasing or decreasing. In this lesson, we're going to go ahead and use f prime of x to help us determine additional information about the graph of f of x. But first, we need to go ahead and we need to define what we're going to talk about today, which is extrema. What is extrema? Well, we have two types of extrema. We have absolute or global extrema, and that is defined as, let f of x be defined on the closed interval a to b, with a less than or equal to c less than or equal to b. So there's some value c on an interval. If f of c is greater than or equal to f of x for all values of x in a to b, then f of c is the absolute maximum value of f of x on that interval. Now, if f of c is less than or equal to all values, all function values, f of x for all values of x in a to b, then this is the absolute minimum value on the interval a to b. Now this is very, very easy. The absolute or the global extrema, it's just the greatest value on the graph or on the function for a given interval. Relative extrema, okay, and this is more common. Relative, or what's also known as local extrema. If there is an open interval containing c on which f of c is the maximum, then f of c is the relative maximum. If there's an open interval containing c on which f of c is a minimum, then f of c is a relative minimum. Very, very simple. If it's just smaller than all of the points around it, it's a relative minimum. If it's bigger than all of the points around of it, like a hilltop, it's a relative maximum. Okay? So, what does this mean in less technical terms? Well, let's go ahead and we'll talk about height. Let's say you're the tallest person in your class. Well, then you are the global or absolute maximum for your class period. But what if we were talking about the school? Well, relative to your classroom, it would be a relative maximum, right? Relative to everyone around you, you're the tallest person, but in the school. What about the school district? What about in the entire state of California? Are you the tallest person in the world? Well, it depends upon what set or what interval you're talking about, and sometimes the whole function, okay? So let's go ahead and let's look at these terms. All right, a relative minimum. A relative minimum occurs when f of x stops decreasing and begins to increase. Okay, so if we're going to define this, begins to increase. Okay, a relative maximum. Well, this occurs when f of x stops increasing and begins to decrease. Okay, and so I'll go ahead and I just want to draw a quick little picture of this so you can get a visual. So here I have y value, x value, and I'm going to go ahead and I'm going to draw this curve right here. Okay, so we can go ahead and see in this case a relative minimum would be this example right here. Here's a relative minimum, and then a relative maximum would just be a point taller than all of the other ones around it. Okay, absolute minimum. An absolute minimum. Well, this occurs when f of c is less than or equal to all other values of f of x. All other f of x values. Okay, in a visual, this absolute minimum right here. Here is your ABS minimum. There's your absolute minimum. And absolute maximum, well, same idea, except it's greater than or equal to all f of x values. Okay, and so that would be right here. This is the absolute max. Now, absolute max and absolute min are important, and in today's lesson we're going to mainly focus on relative extrema, and we're going to come back and talk about absolute and global max and mins and how to find them later on. But first, let's go ahead and look at example number 1. All right, so here we have a graph of f of x, and they say label any points that are relative and or absolute extrema. Okay, so just looking at this, I'm going to go ahead and the first point I'm going to define is right here, that this is 2, -1. And this is a relative minimum because it is lower than all of the other points around it. Okay, so relative minimum. As well as on this graph, you can see here, it is the absolute lowest point. So this is a global or an absolute minimum as well. Okay, so there is a relative min as well as being the global minimum. Okay, the next point that we're going to go ahead and talk about is 5, 2. Now 5, 2 is a relative maximum. Relative maximum because it's greater than all of the other points around it. Okay? All right, next we have 7, 1. 7, 1 is a relative minimum. Again, because it is lower than all of the other points around it. As well as we have our last point over here, right here, and that is 11, 5. Well, 11, 5. 11, 5 is a global max, a global maximum. Okay? All right, so those are just some of the relative mins and maximums. All right, now we're going to go ahead and talk about the first derivative test. So how do I go ahead and determine relative extrema? And again, like I told you, we'll come back to global extrema in a later lesson. But how do I find relative extrema? How do I know if it is a min or a max? Well, we're going to use the first derivative test. And the first derivative test should give you a clue of what we're going to do. We're going to go ahead, and this really builds off what we did in the last lesson. The first thing that we're going to go ahead and do is we are going to find the critical values of f of x. Now note that involves finding out when is my function, the derivative, f prime equal to 0, or when is it equal, or when is it undefined. Okay. Number 2, you're going to go ahead and you're going to create a sign chart for f prime of x, and this is just like what we did in the last lesson. Okay, and then what we do, the last thing, similar to what we did the last time, we check where x changes from negative to positive. Think about this for a minimum. Where is my function changing from decreasing to increasing? Or for a relative maximum, I want to know when does f prime change from positive to negative, right? I'm increasing, f prime is positive, now f prime is starting to go negative. There was a relative max there, okay? And then your justification is just what we talked about. F of x has a relative minimum at x equals c because f prime changes sign from negative to positive, or from positive to negative, okay? And if you're just speaking in general about relative extrema, you can say that it changes signs. Now here's the beautiful thing. This is redundant of what we did in the last lesson. So the good thing is we can go ahead, we can use one process in order to find where the intervals are increasing and decreasing, and that information will allow us to tell, do we have relative extrema? If our sign changes, there's relative extrema there. Okay, and specifically if we change from increasing to decreasing, it's a maximum. From decreasing to increasing, that is a minimum. Okay, so let's go ahead, let's look at example number 2. F of x equals negative 1/3 x cubed plus 3/2 x squared plus 10x plus 3. Find any relative extrema for f of x. Give a reason for your answers. Okay, so I need to find relative extrema, and when they say that too, they would like the actual function values. So I'm going to go ahead, and the first thing I'm going to do is I'm going to take a derivative. So I need f prime of x. That is equal to negative x squared plus 3x plus 10. Okay, so there is my derivative. Now what I'm going to go ahead and do is I'm going to change my signs. I'm going to set it equal to 0, and I'm going to solve this. And I solve this by factoring. When is it equal to 0? So I'm going to go ahead and factor out a negative. And that's going to change my signs. And then I'm going to go ahead and factor this, break this down into two binomials. So we have x minus 5, x plus 2. And then I will go ahead and use my zero product property. So x minus 5 equals 0, x plus 2 equals 0, and we get x is equal to 5, x is equal to negative 2. Again, here are the critical values. There's your critical values, okay? So next, step number 3, I'm going to go ahead and I'm going to create an f prime number line, and I'm going to place my values, negative 2 and 5. And then we're going to go ahead and you can test, right? So I can test and see, okay, what are the values for this? Or you can kind of use your knowledge of this function. This is a negative parabola. So you can think of a downward facing parabola. It's going to look something like this, okay? So if you were to test, maybe I would test f prime of negative 10. If you go ahead and plug this in, you're going to get a negative answer. If you test f prime of 0, the best one to test, you get a positive 10. And then f prime of 10, that would give you a negative, okay? So we have negative, positive, negative. Now, if you wanted to kind of visualize this, like what's happening? F prime is negative, then it's positive, and it's negative. Well, my graph, my function value, my function's decreasing. Then it starts, well, actually, I guess let me go back. Here we go. It's decreasing, then it's increasing, and then it's decreasing again. Drawing this little picture over the top of your sign chart can really help you visualize, hey, where's my function decreasing, where is it increasing, as well as the extrema here, okay? So they say, go ahead, find the extrema. So what I want to do is I want to use these x values. I know I have a relative minimum at negative 2, so I'm going to plug this in, and we get negative 8/3 plus 3/2 times 4 plus 10 times 2 would be 20 plus 3. Okay, and believe it or not, this all ends up working to be negative 25/3. Negative 25/3. And then if I do the same thing for 5, I'll just go ahead and evaluate 5. We get negative 125/3 plus 75/2 plus 50 plus 3, which this ends up being 293/6. Okay, so I have the function values. A lot of times they'll just ask you for the x values, like what's the x value of any extrema, and then identify them. So here we're going to go ahead and we're going to say f of negative 2 equals negative 25/3 is a relative minimum. Because, why? What told us this? Well, because f prime changes from negative to positive. Negative to positive. Okay, and if you wanted, you could include at x equals negative 2. Okay, next idea. All right, f prime of 5, which equaled 293 over 6, is a relative maximum because f prime changes from positive to negative. At x equals 5. Okay, and there you have it. There is your extrema. Okay, and again, if they asked you if it was increasing or decreasing, you could easily tell this because you have that information. All right, so let's go ahead and look at example number 3, and example number 3 does just that. They say let g prime of x equal 3x squared times x plus 4 times x minus 5, and we want to find the intervals where g is increasing, where is it decreasing, and then to find the location of any relative extrema for g. Okay, notice step 1 already done. I am already given g prime. So in order to do the first derivative test, the first derivative is already given. Now what I'm going to do is I'm going to set it equal to 0. Now the beautiful thing too is this is already in factored form. I don't have to go ahead and factor that. I can just use the zero product property. So I have, I have two x equals zeros. X equals 0, x equals 0. You're only going to take one of those. X plus 4 equals 0, x minus 5 equals 0, and we can go ahead and solve this. So x is equal to 0, x is equal to negative 4, x is equal to 5. Okay, so I'm going to go ahead and I'm going to draw a f prime number line. Maybe, that's fine. Here we go. And not f prime, we'll call this g prime. And our critical values are negative 4, 0, and 5. Okay? So what we need to go ahead and do is we need to test. I need to go ahead and plug some stuff in, see what's going to happen. So let me check here. What's g prime of negative 10? So that's going to be a positive if I plug it into my first term, right? This is 3x squared. Everything's going to be positive there. X plus 4, that's going to be negative. X plus 4, that's what I'm plugging it into. And then x minus 5, that is also negative. So positive, negative, negative, this gives me positive. So I know g prime is positive there. Okay, g prime of, let's go negative 1. If I plug in negative 1, we get a positive. Negative 1 here is going to be a positive. Negative 1 here is going to be a negative. So this is negative on this interval. Okay, next, g prime of 1. Go ahead and plug in 1. We get a positive, positive, and it looks like a negative still. Still a negative, okay. All right, and then g prime of, I'll just use 10, positive, positive, all that's positive, okay, positive. So there you go. All right, so do I have, I can clearly see where I have increasing, decreasing intervals, but do I have any extrema? Where is the extrema? So here on this interval, I'm increasing. Here I'm decreasing. Here we continue to decrease, and then we start to increase. Okay, so I'm going to do increasing, decreasing first on this interval. So we can say g is increasing on negative infinity to negative 4 union 5 to infinity because g prime is greater than or equal to 0. G is decreasing on, it looks like -4 to 5. Why? Because G prime is less than or equal to 0. Okay. And then how about Extrema? Well, it looks like we have a maximum at x equals 4, and it looks like we have a minimum at x equals 5. Okay, so we can go ahead and say, okay, g of -4 is a relative minimum because G prime changes. Did I say minimum? I was testing you guys. Thank you for telling me. Maximum because G prime changes from increasing. Actually, I don't want you to say that. G prime changes from positive to negative. Now, if you said increasing and decreasing, that would be false because G prime here is not increasing. It's positive. Increasing talks about the slope of whatever, okay? So, and you always want to use calculus. You always want to use the derivative. So G prime. You don't want to say as a relative minimum because G changes from increasing to decreasing. You want to use calculus. Okay, so there's my first one, and then my second one, G of 5 is a relative minimum because G prime changes from negative to positive. And I'm going to include this at x equals 5 here, at x equals -4. Okay? All right. That is how you find relative extrema. Points that are just a little bit bigger or smaller than other points around it. And how we do that is by using the first derivative test. Where does a function change from increasing to decreasing or decreasing to increasing? Okay? I'm going to have a part 2 where we look at f prime graphs and interpreting relative extrema. Go ahead, check that video out. Give me a thumbs up, like, subscribe. Catch you in the next video. See ya.